Hello and welcome to this short video from Leader, an introduction to hybrid IP and SDI reference sources. My name is Kevin Selfridge. I'm the European Regional Development Manager for Leader Europe, based in London in the UK. And if you have any questions concerning this presentation or any Leader products, please don't hesitate to contact me on the numbers currently displayed on the screen. So today we're going to look at reference signals and why they are absolutely critical to any part of the broadcast operation. So let's have a look at some of the terminology that's used, and we'll start off with GenLock, which is a common technique where the video output source or a specific reference signal from a signal generator is used to synchronize other television sources together. And this is critical because when we switch between video sources, we have to follow the SMPTE standards. And this is to ensure that we have a smooth transition from one source to another, and we do not interrupt the quality of service and provide the viewer with an unpleasant experience. So in broadcast systems, an analog generator lock signal, usually consisting of vertical and horizontal synchronizing pulses, together with a chrominance phase reference in the form of color burst. No picture information is usually carried to avoid disturbing the timing signals. And the name reference, black and burst, color blur, and black burst is generally given to such a signal. And although some high definition broadcast systems may use a standard definition reference signal as a generator locking reference signal, the use of tri-level synchronization pulses directly relating to the frame and line rate is being increasingly used with HD systems. And now we have IP infrastructure, which requires new timing reference systems based upon the IEEE 1588 standard. So let's have a look at the broadcast world and the infrastructure that we're also familiar with in SDI. We'll start off with a remote venue with an OB truck with cameras connected via SDI, and the OB truck will have a video sync generator reference source. Those signals from that truck may well go back to a studio where they will cut between that and pre-produce content, which may include archive footage or highlights from part of the event. This will then go through the central machine room to the master control room before it leaves the building. And again, these will all be connected to a video sync generator reference source. And then finally, we go to the broadcast playout center. And as you can see, all three of these venues have their own reference generator. So if you're working in a live environment where they all need to be synchronized together, then we will use a global positioning system to ensure that they are all accurately timed together. Now, Leader has the LT4610 video sync generator, which is specifically designed to provide reference sources for SDI facilities. We have our GenLock in. We have 6 analog blackouts, and these are all independent. So therefore, making it ideal if you're working in a live international production environment where you've got multiple different formats. We then have SDI out. We then have our analog references with AES EBU out, silence out, and word clock out. And finally, because these devices cannot afford to fail, we have redundant power supplies. There's also an Ethernet port for remote control and monitoring. Then, to connect to the GPS system, we have the SCR01 option. And for those clients working with UHD and 12 gig, we also have the SCR02 option. So if we go back to our facility, here we see the 3 venues, each with a video sync generator connected to the global positioning satellite. But typically, we need that resilience. So what most facilities have are 2 video sync generators with an emergency changeover unit. And this detects an error on the primary and will switch to the backup source. And Leader LT4410 provides such functionality. And it can support up to 11 pairs of BNC and LTC cable. And these can be SDI, NTSC, PAL, Black and Burst, HD, Tri-Level Sync, AES EBU, digital audio, word clock, and LTC signals. And it can be used in combination with the LT4610 and 4611 video sync generators from Leader. To connect the two together, we have the LC2183 conversion cable. And this is a 25-pin D-sub LTC connector with two 15-pin D-sub LTC connectors. It can be used to connect the primary and backup to the LT4610. It can also be used to convert to 3 XLR connectors for LTC output. The cable length is 1.5 meters. We then go back to our 3 facilities, and you can see now that this is a much more typical setup and installation with a pair of video sync generators and an emergency changeover unit, all connected to the Global Positioning System satellite. So when we now move into the world of IP, the 3 venues are now connected via a wide area network. And we have a PTP generator. And again, to make sure that all 3 venues are correctly timed, we will use a global positioning system, as we did in the SDI world. So let's take a look at the PTP system, its architecture, and some of the terminology you're going to hear. To start with, we have the Grand Master Clock, and this is the ultimate source of time for clock synchronization using PTP. The Master Clock is a clock that uses the source of time to which all other clocks on the path are synchronized. We then have a slave clock. This is a clock that may synchronize to other clocks. Transparent clocks. Resident time is measured for every PTP packet. Timestamps are drawn at ingress and egress, and differences is added to the correction field. And this is ideal for small scale systems. For larger systems, we're looking at a boundary clock, where every port acts as a PTP node, or ordinary clock. Time is regenerated and forwarded to all slaves. And this, as I said, is suitable for larger systems. We then have the best master clock algorithm, and this is used to automatically select the Grand Master. And PTP domain is a logical grouping of clocks that synchronize to each other using PTP, but may not synchronize to other clocks in other domains. So let's have a look at the best master clock algorithm and how it works. And as we said, this is key to the resilience of a PTP network. The best master clock algorithm allows a clock to automatically take over the duties of the Grand Master when the previous Grand Master loses its GPS, gets disconnected due to switch fault, or for whatever reason is unable to continue as the Grand Master. And this is achieved by the device announcing itself on the network. And when it announces itself, it then announces its parameters. And if those parameters are superior to any other clock on the network, it becomes the Grand Master. If it's not, then it simply becomes a slave and will keep polling until the Grand Master fails and it takes over its place. So here we have a display of the best master clock algorithm from the Leader LV4610 True Hybrid IP and SDI waveform monitor. And here you can clearly see it's displaying the original timestamp, the UTC offset, priority 1, clock class, clock accuracy, clock variance, priority 2, clock identity, and steps removed, and time source. And these are used to identify the best clock to become the Grand Master. If 2 devices should have exactly the same, then the final arbiter will be the MAC address of the device. There's no 2 devices can have the same MAC address. So in summary, the best master clock algorithm results in no need for an emergency changeover unit. Gone. So If we now look at our network, here is our IP infrastructure. But as I said, most people work in a hybrid world, so they'll have both IP and SDI and require reference sources for both systems. And this can cause problems. So ideally, you want your IP and your SDI to be in the same device, which means that they are timed together and then over a wide area network are connected to the global positioning system together. But how does this work? As we said, the best master clock algorithm results in no need for an emergency changeover unit. But what about hybrid IP and SDI environments? We could end up with the IP PTP coming from one device and the SDI sources coming from another. So Leader has thought of this, and in the event of a failure of the LT4610, it would send an SNMP trap on the switch and send an SNMP set to change the state on the LT4448, so that should the best master clock algorithm cause a switch, the SDI references will follow. So Leader has also added to the LT4610 a PTP option. This is SCR03, and this means now that you have both your SDI references and your PTP references in the same unit, which is going to considerably simplify your network timing. Like the Leader Zen series, there is an ordering guide for the LT4610, which allows you to step through and select the hardware and software license options you need to configure the device for your requirements. Now, for those people starting with IP with a proof of concept, Leader has the LT4611, and this is a scaled down entry-level version of the LT4610. We have the Ethernet, we have Gen log in, we have analog black out ×3, silence out, word clock, and also dual AC inputs. And this unit can have the SCR03 PTP interface added, making it a very cost-effective IP PTP reference solution. Should you require more of the traditional SDI features, they're available. We have the GPS signal interface. We have the AES EBU out interface. We can add another 3 black and burst outputs. We can add SDI outputs. And we can add the 12 gig UHD outputs, making it equivalent to the LT4610. And again, there is a very simple step-by-step ordering guide. So in summary, it is highly unlikely that any production or broadcast facility will be entirely IP. Therefore, a hybrid IP and SDI reference source will be required. Having separate IP and SDI reference sources results in complicated reference time in management. These can be significantly simplified by having both the IP and SDI reference signals in the same reference source. And with over 65 years of experience in the broadcast industry, Leader's LT4610 and 4611 are the ideal solution for broadcasters as you start your IP migration. So thank you once again for watching. If you have any questions, please don't hesitate to contact me. If you enjoyed this video, please like it, and please subscribe to the Leader Europe YouTube channel, where we'll keep you updated with the latest developments on Leader's products. Thank you.